Introduction to exponents. An exponent is a notation that indicates the number of times a base multiplied by itself. For example, in the expression 2 to the 3, 2 is the base and 3 is the exponent, meaning 2 is multiplied by itself 3 times. Base and exponent, in the expression a to the n, a is the base and n is the exponent. The base represents the quantity that's being multiplied, while exponent shows how many times to use the base multiplication. The structure is pivotal in exponential operations. Exponents follow several key properties. The product of powers properly states that a to the m times a to the n equals a to the bracket m plus n bracket. Another is the power property, where bracket a to the m bracket to the n equals a to the bracket m times n. Understanding these properties is essential for simplifying expressions effectively. Positive exponents. Positive exponents indicate repeated multiplication of a number by itself. For instance, 2 to 3 means 2 multiplied by itself 3 times, resulting in 8, highlighting the growth of mathematical expressions. Negative exponents signify the reciprocal of the base raised to the absolute power of the exponent. For example, 2 to the negative 3 equals 1 divided by bracket 2 to the 3 bracket, which simplifies to 0.125, demonstrating how exponents can represent fractions. Any base raised to the 0 power equals 1, regardless of the base, with the notable exception of 0 itself. For example, 5 to the 0 equals 1, thus introducing a fundamental rule across various exponential functions. Fractional exponents represent roots. The numerator indicates the power, while the denominator indicates the root. For example, x to the 1/2 signifies the square root of x, an integral in solving equations involving radicals. The definition of roots: a root of the number is a value that, when raised to a certain power, produces that number. For example, the square root of 9 is 3 because 3 raised to the power of 2 equals 9. The square root of a number x is a value that, when multiplied by itself, equals x. For instance, the square root of 16 is 4, which means 4 times 4 equals 16. Cube root of a number y is a value that, when used 3 times multiplication, equals y. For instance, the cube root of 27 is 3, since 3 times 3 times 3 equals 27. Higher order roots refer to roots beyond square and cube roots, such as fourth roots or fifth roots. For instance, the fourth root of 16 is 2 because 2 raised to the fourth power equals 16. Product of roots. The product of two roots can be simplified using the radical property. Square root of a times square root of b equals square root of bracket a times b bracket. This property allows for easier calculations and simplification when handling roots and algebraic expressions. The quotient of two roots follows the property square root of a divided by square root of b equals square root of bracket a divided by b bracket. This means that dividing roots can also be simplified, providing a useful tool in equations involving square roots. Roots can often be simplified to the simplest form by factoring out perfect squares. For example, square root of 18 can be simplified to 3 times square root of 2, enabling easier computations and algebraic expressions. Common questions about exponents. What is an exponent? An exponent indicates how many times the base number is multiplied by itself. For instance, 2 raised to the power of 3, bracket 2 to the 3, bracket equals 8, as it represents 2 times 2 times 2. This notation simplifies calculations and represents large mass numbers efficiently. What is a root? A root answers this question: what number, when it multiplies by itself a specific number of times, returns the original value. For instance, the square root of 16 is 4. Since 4 times 4 equals 16, roots simplify fractional values and help in various calculations. Exponents are useful in calculations involving growth rates or permutations, such as compound interest, where the value increases exponentially over time. Roots are key